I'm Danilo Pianini, a postdoc at the University of Bologna. This talk is about a technological transition performed mainly by a brilliant engineer and former student of mine working at Mazzoli SPA, the company subject of this study. We evolved a legacy monolithic software system into a more modern microservice-based architecture, and we changed the working habits of the development team through the adoption of DevOps philosophy. Before beginning the operation, we selected and measured some metrics that we deemed relevant to understand if and how the novelties impacted the development process. We also performed interviews before and after the transition. Towards the end of the presentation, we will see how these metrics changed after the transition. The company, Mazzoli, is a large multinational based in Italy, counting about 2,000 collaborators worldwide. However, the internal team in charge of the application we are discussing was composed by just 5 people. 1 lead, my co-author, 1 QA manager, and 3 developers with different skills and seniority. The company's core business is editorial services, and the system at hand, codenamed SysRed, is a client-server application geared towards professionals in law. The company pays so-called editors, domain experts, to enter information through the client. The data are stored in a database and exposed to users paying a subscription for an updated source of legal information. The initial architecture was composed of a standalone graphical client written in Delphi, directly communicating with the server. Let's take a look at the metrics and the major related issues. The release frequency is how often the team releases a new stable version of the application per day. In the beginning, once every 2 weeks or so. It's related to another metric, the commit to release time, namely how long it takes for a recorded state of the code base to be delivered to the final user. The former time, 8 to 24 hours. These times were primarily a consequence of the formalized yet largely manual release procedure, commitment of changes to the SVN repository, creation of executables through the IDE, manual update of the database from staging to production, including schema and stored procedures, manual testing of the UI functionality, and delivered to the editors via email. So yes, the final product was sent to editors as an attachment to an email. The team performed 2 commits per day on average on the trunk branch of their SVN, usually at the end of the working day. The versioning system was actually being used more as a backup for code rather than a real content management system. The mean time to recovery is how long it takes to recover the functionality after a major failure. 36 hours in the original system. The metric is relevant as the company had more than once actually had issues with crypto lockers, which required to resurrect the system from backups. The metric relates to the production environment setup, which was about 16 hours. The primary issues there is that it required opening a ticket with an external company-wide operations team, and they could take days to provide an instance of Windows Server with a compatible version of SQL Server. The development environment can be set up faster, in about a couple of hours. A PC with a fresh installed OS is ready to be used for development. The application used to have a nightly downtime for backups. Although the product is meant for the Italian market and Italy doesn't span multiple time zones, there are plans to expand to other markets. Hence, 30 minutes of daily scheduled downtime don't exactly bode well. Finally, 2 metrics are related to tickets. The support ticket frequency is how many requests for help or bug reports were opened to the support team, and initially about 40 per month. The issue resolution time is how long it took on average for one such ticket to get closed. The average time was 4 days. Further detail on the initial state of the operations are in the manuscript. I just want to mention that there was no automated QA whatsoever, no static analysis, all testing was performed manually. I won't spend much time on the technical details of the transaction either. Again, you can find them in the manuscript. I will just mention some hotspots. The architecture changed entirely from this to this. In a classic divide and conquer, the features of the former monolith were split into lightweight containerized services. The team switched to Git and adopted a branching model inspired by the Git flow that mapped the actual development phases to branches. The team set up a continuous integration and delivery pipeline with the automated QA, including static analysis and automated testing, covering single microservices and end-to-end use cases. Containerization allowed the team to be more independent of the external operation team. Before looking at the final metrics, I'd like to show you the timeline. The microservicification of Sysred was approved in 2016. Metrics were taken 1 year after, and the first release using the new infrastructure was performed in July 2020, and the version I'm presenting now was operational since spring 2021. The reason why it took so long does not concern technical aspects. Instead, the single most challenging thing is convincing non-computer science people that changing the software production process is beneficial. Editors, namely our domain experts, were highly skeptical. They were used to the old system, including its shortcomings, and they could not understand why it should be changed. It worked. What really sparked interest and enthusiasm in pressing a dramatic acceleration was a demo of a partly working prototype of the 2B web interface with AI-assisted tagging for legal documents. And the second biggest accelerator, unfortunately, was the current pandemic, as editor wanted to run the application from devices other than their Office Window PC. So as promised, let's now take a look at the final metrics. Release frequency increased 37-fold. Commit to release time was slashed by approximately 98%. Commits per day have more than doubled. The mean time to recovery was reduced to about half an hour, as the production environment could be set up in about 20 minutes. The development environment setup requires now 9 minutes, and the nightly downtime has become a thing of the past. It's to 0. The support tickets frequency improved much less. It just halved. Likely because now there is appropriate testing in place, including regression testing. And the issue resolution time improved by just 25%, as the bottleneck there was the development time required to fix the issue. In conclusion, conversion to microservices and DevOps from traditional methodologies can bring enormous benefits. Practices should be tailored to the team size and habits and evolve with it. It is very hard to convince known experts, including management, that improvements to the process impact the quality of the application and related services. Thank you for your attention.